Hello guys, welcome to my channel. This is the solution to the qualifying examination for applicant for Japanese government Monbukagasho scholarship. Specialized training college students, mathematics 2006. And please note that this test period is 60 minutes. Okay, let's start. Problem 1, question 1. We are asked to simplify the square roots of 5 minus 2 the square root of 6 minus 1 over the square root of 2 plus the square root of 3. For the first part, we can write 5 as 3 plus 2, and for the second part, we will rationalize the denominator by multiplying the top and the bottom by the square root of 2 minus the square root of 3, which is opposites to the bottom. So the top will be the same, but the bottom will get into the formula, the squares of the square root of 2 minus squares of the square root of 3. And then for 3 we can write it as squares of the square root of 3, and the same as 2. And we can see that we can separate the middle part as 2 square root of 3 multiplied by the square root of 2. So we can see that it gets into the formula a squares minus 2ab plus b squared. So it will become a plus b squares. And for this second part, it will get into 2 minus 3, so 2 minus 3 will result minus 1, and then minus 1 meets minus 1, it will get a positive 1, so it remains only the top squares root 2 minus the square root of 3. So as it has the square, so it can come out as the square root of 3 minus the square root of 2 without the absolute value, because it is positive, since square root of 3 is greater than the square root of 2. And for this, square root of 2 minus the square root of 3, so the equation becomes 0. 2 squares minus 2x squared y to the powers of 3 divided by cube minus x y to the powers of 2. So we can write it as a fractions, that the top is this and the bottom is this. So according to the its properties of exponent, minus 2 takes square become 4, and x square become x to the power of 4, y 3 multiplied by 2, so it become y to the power of 6. And we do the same at the bottom, so we can cancel the y to the power of 6, and 4 divided by minus 1 is 12 minus 4, and x to the power of 4 remains x after cancel with x cubed. Question number 3. We are asked to solve the equation 4 to the powers of x minus 2 to the powers of x plus 1 minus 15 equals 0. And please note that it is exponential equations, which we have to write into this form. So it has the same a to the powers of x, so we can substitute it by any letter which is positive for all x, so that we can solve these equations easily. Notice that we can write 4 to the into the 2 to the powers of 2 and to the powers of x, and we separate this into 2 multiplied by 2 to the powers of x, and we change the positions of the exponent so that we can see 2 to the powers of x. The same, we substitute it by t, which is positive for all x, so it will become t squared minus 2t minus 15 equals 0, and we have a quadratic equations, so we can write in the product form factorizations into t minus 5 multiplied by t minus 3 equals 0. So it means that t equals 5 and t equals minus 3. We must reject t equal minus 3 because it is negative. So we take only the positive one, t equals 5. But t is 2 to the powers of x equal 5. So in the definitions, we can write x equal logarithm of 5 to the base of 2. Question number 4. We are asked to solve the equation 2 cosine x to the powers of 2 plus 3 sine x minus 3 equals 0. And please note that the x is always larger or equal 0 degree and smaller or equal 180 degree. So it is the condition. Okay, so we are asked to find the values of x which satisfy this equation. So the key in order to solve these equations, I mean trigonometric equations, if we see there is only sines and cosines, so if either any of them has the squares on it, we need to transform it to another equations. Based on the Pythagorean identity, sine x squared plus cosine x squared equal 1. So we can find each one that's related to other. So for cosine x to the powers of 2, we substitute it by 1 minus sine x to the powers of 2, and the rest are the same. So we take 2 into the equation. We can have 2 minus 2 sine x to the powers of 2 plus 3 sine x minus 3 equals 0. So we rearrange the equations. We can have minus 2 sine x to the powers of 2 plus 3 sine x minus 1 equals 0. So we can substitute by t that equals sine x. We can have minus 2t squared plus 3t minus 1 equals 0, and we factorize it. We can have minus 2t plus 1 multiplied by t plus 1. So when it's coming to this, we can find the values of t. So the first t is 1 over 2 and half. So since t is it's equal sine x, so we return it back. so equal 1 over the half. And we know that for sine x that equal a half, we can have two angles. The first one is 30 degree that equal pi over 6, and the next one is 150 degree that equal 5 pi over 6. So it has the two solution, and this two it satisfy the conditions that given because it's between 0 and 180 in the first and the second quadrant. And for t equal 1, sine x is equal 1, so the only values of x, the angle is only 90 degree that equal pi over 2. So this is the solution. Question number 5. There is a sequence an, and at a time the first term equal 1, second term equal 2, third term equal 5, and fourth is 10, and then 17. And we are about to find the eighth term. So as we observe each of the term of the sequence, a1 equal 1, a2 equal 2, 5, 10, and 17. So we can see that it's different from each other is 1, 3, 5, 7, and you can see that from 1, 3, 5, 7 it is arithmetic sequence with its difference is 2. So whenever it's come to the next term, we need to plus the next number that is uh, arithmetic sequence. So if here 1, 3, 5, 7, and then we plus 2, it's 9. So we need to um, add another 9 to have a 6. So it's become 26. And then 9 we add 2, it become 11, and we add another 11 from a6. We can have the 7th term 67, and then 11 plus 2 is 13, and we add another 13 to the a7, we can get the answer. So it is 50. But however, if this problem is determined to find the general term, so we need to do by this way. Okay, so I just make up this problem. So we need to create a new sequence is bk equal ak plus 1 minus ak, that k is um, in the set of the natural number that begin from 1. So we can get b1, the first term of the sequence b1 is equal 1 plus 1 is 2, so a2 minus a1, then k equal 1. So we subtract the second term and the first term, we have 1, and we do the same like all the terms, so we can get 1, 3, 5, 7. And at that time we can see that it is a arithmetic sequence with its difference equal 2. So we can find the general term of the b sequence. It's b1 plus k minus 1 multiplied by its difference. So k here is the number of the term, so it has k term. So after calculated we can have 2k minus 1. So as we can see the new sequence that we just created, bk equal ak plus 1 minus ak, we can have the term of it. The first term is we just substitute k plus 1 into this equations, we can have a2 minus a1 and all the same for other term. And as we are determined to find the general term of a, so we must stop at an. So in order to get an k, this it become n minus 1. So when it's a minus 1, it's plus 1, so it become an, and that term we need to find it. So we stop here. So when we do the sum, all of this, we can see that we can cancel second term with the and the first and the second, and 3 with here, so here with here, and 3 with 3 a 3, and this fourth term with its fourth term, plus and minus, it's cancel each other, and this will be cancelled in the next term. So it will cancel until this an plus 1, because as we can see uh, on the top, it's always cancel from the first, so it's gonna cancel from the first, and here remain because it cannot be cancelled. It can be cancelled only if there is more term continue. So we can sum up here, so we can get the sum of bi that I from 1 to n plus 1, and it's equal, we remain an minus a1. So we already find this, right? So we need to have this, and that's for the sum of bi that I from 1 to n plus 1 minus plus a1 here. And then we know that bk is equal to 2k plus 1, 2k minus 1, so bi is become bi plus 1. And I'm gonna review you some of this formula, and which we can use, that the sum of 1 to n, it is the sum of the arithmetic sequence, but if it's n with n plus 1, it will become like this, and here, and this I, it will become n multiplied by n minus 1 over 2, and 1 here minus 1 here, it's become n plus n minus 1, because it's the sum of 1 from 1 to n minus 1 time, so it's become n minus 1, and here 1 the same. So after calculating, we can have the n equal n squared minus 2n plus 2, so we can substitute 8 into it, so we get 50, like uh, the first that we get. And it's just the formula for you just need to remember. So we can either do this two way, but if we know this way, it will be easy if the problem is asked to find the general term or find any term that is very large, for example find a 100 or something, so you can do in this way. So thank you.